Hello, and welcome to this session on Power Apps availability testing. My name is Ali Yousefi. I'm a Principal Cloud Solution Architect with Microsoft. You'll find my email and LinkedIn information on this slide. Some of my certifications include Azure DevOps, Azure Solutions, Dynamics and Power Platform, Architects, as well as MCT, and then some MCSE Cloud Platform Infrastructure Business Applications. In this session, we're going to start with an overview. We're going to look at testing options, move to monitoring options. We'll define a test strategy. We'll do a demo of that test strategy, and we'll wrap up with some references, next steps, and conclude. Let's start with an overview. So, why do we want to test for availability? Well, we know that our users are making apps, they're being more productive, they're finding these inefficient manual workloads and working to make them be more efficient with Power Apps and the Power Platform. From a Gartner report, we've seen that 88% of service leaders say that their current QA processes are ineffective and rarely match up to the customer's view of quality. So while we do have makers who are building these apps, helping automate and empower the organization, we want to look at how we can move from that, getting them in productivity into quality. So how do we harden that application, make it ready for the enterprise, find those mission critical applications and really apply quality to them. Availability testing will help here by ensuring that the app is running, right? Is in performing. So when it's opening, for instance, when it's launching, we want to make sure that it's going to launch well. Availability testing helps us reduce risk, right? So if it's not opening, we can quickly act upon alerts as part of the goal of availability testing, be alerted, start looking at how tests are being launched from different locations around the world. It helps us optimize efficiency, right? When we're availability testing, as we go through ALM processes, for instance, and automating deployments, we can also ensure that the app is up and running once we've, say, deployed and published the latest version of it. Let's take a look at some testing options. Traditionally, when we're building applications, be it Power Apps, be it traditional web applications, console applications, as developers, we sort of focus here on the shift left. We start thinking about, unit testing and requirement, making sure that it's that our app is meeting the requirements, that there's no bugs, for instance. That's traditionally considered sort of the shift left side of testing. For this scenario, we're actually going to look at shift right. So we're going to be looking at, just making sure that the app is up and running. How can we collect feedback from the app? So, is it launching in a timely manner, meeting business expectations? How does it open when it's say experiencing stress or increased load? So in this scenario, we're actually going to be looking at opportunities to not just ensure that the app is performing business requirements, but it's meeting business expectations and providing us feedback on that. So with that, what options do we have for availability testing in Power Apps? Well, you may not be aware of it, but there's something called Test Studio that is available when you are actually building your app. We'll take a look at it a little bit later in a demo. But this is a manual sort of process where you can build a test within the UI and actually replay that test. So I can build a test, store a URL, for instance, and when I'm ready, I can log in and replay that test and ensure that it's running correctly, it's meeting the business requirements. Traditionally, that is done through a manual process. We have that opportunity, though, with that defined Test Studio test to move into more of an automated fashion. We have automated Power FX tests. So you could take that Test Studio test, which defines with Power FX sort of formula. So things like doing conditionals or things that may be specific to a test. So taking screenshots or doing assertions, right? Making sure that something that we think should happen is happening, running trace and instrumentation, things like that. We can actually automate those tests. So taking something that's defined in a low code, PowerFX language and automating that. We also have opportunities to automate UI. So for instance, launching a browser, navigating to the app, opening the app as a user would, clicking on buttons as a user would, and collecting sort of that telemetry from that. Is this button click successful? How long did it take? Running the monitor tool, that sort of thing. So we have a few options that we can leverage from both manual side to automated. Manual could include the PowerFX using Test Studio, something we'll talk about here coming up called Power Apps Test Engine. Or we have the automated UI test using things such as Playwright and Selenium and so on. We can interact more with the DOM or the app magic side of the house, if you will. Let's take a look at some monitoring options. As we look to test our Power App, traditionally testing, especially in an automated fashion, we're going to be running those tests on some sort of what we would call agent container. Think of a workstation of some sort. So you can run anything from, say, Docker containers to run it. You can use CI/CD build agents to run this. We would look to monitor the logs of the workstation that's actually running our test. So making sure that it's executing the test we want, it's gathering whatever dependencies it needs, it's building whatever test engine that we're ultimately going to run our test on, and it's executing it, right? If there's any failures there, we want to be quickly notified so that we are able to understand and reduce any time of recovery for our testing engine. From there, we also can look at moving into the actual test results. So we have a test engine that runs our test. Those tests run, they produce results. Those results can be anything from telemetry. Those things can be screenshots, artifacts like logs, videos, performance timings. All of those can be considered test results. So our test engine not only needs to be able to execute the test, but needs to be able to deliver some sort of results so that we can further sort of diagnose and see what's happening within each test. Just because a test runs doesn't necessarily mean it meets what the business is expecting. That's where we look at shift right testing to make sure it's working the way we want. If we're just looking for a test to run, that might be more of a shift left, right? We're looking at just making sure that it meets the requirements. It loads, buttons do this, controls do that. We also want to be able to have tests that tell us and test results that tell us, how is it running? Give me that feedback loop here. And that's where the test results and artifacts will help provide that feedback. Some other monitoring we can do is we can leverage the cloud, in our case, Azure Monitor, full suite of monitoring from log stores to store the logs and artifacts we have. We have anything from data lakes to store the actual artifacts, such as screenshots, hard logs. We can do log analytics for storing logs from containers. We can use App Insights and Log Analytics for storing and diagnosing logs from the application. So Power Apps by default can natively connect to App Insights by inserting an instrumentation key onto the app object. We'll be looking to leverage that. Container logs, the workflow runs, the check suites and so on inside of GitHub, or the build pipeline logs within Azure DevOps, for instance, can also be funneled into Log Analytics. So we look at the application layer. We look at the infrastructure that's running, right? The system that is running, the container that's running it. So we have sort of two layers that we want to monitor here. We can quickly add alerts. We can add reporting, etc., using Azure Monitor and Azure Monitor alert rules. Let's look deeper into a test strategy. Power Apps testing strategy. In this scenario, I've laid out some guidelines that we are going to adhere to as we look in building a testing strategy for Power Apps. These are ones that I've defined There could be more that that aren't listed here that we also want to take into account. But these are ones that I think are something that we should have not only within Power Apps, but really app testing in general, right? So looking at the first one, we want to make sure that the app is launching correctly and it's also meeting the performance baselines, the expectation that the business has for the app to launch. The tooling that we're going to be using for testing, it must eliminate or at a minimum reduce the risk as much as possible of not being able to run, reducing any dependencies it has. It needs to be it needs to meet the requirements of having minimal dependencies, be very low complexity, right? We don't want to have anything that's going to be too complex to require too much maintenance, for instance, right? So we're looking at how can we take a tool and not have to worry about supportability, maintainability, and so on. So that's going to be something that's a key for us as we look at what tools we have. There's many tools out there, open source tools you could pay for. So we need to take all of that into account. Do we feel like that we want to buy something that may be licensed that has support behind it? Do we want open source where we could see exactly how the code runs? And if we do open source, do we want to take ownership of that source, bring it locally, make it our own? And if so, what's our supportability strategy for that? Moving along, the test results. Once we've run the test results, they have to provide as much information as possible. That means they have to have logs. We must have the ability to collect screenshots to see that the app actually did load, it launched, it rendered as expected. This is important as we start looking at testing on the UI of apps. Our test reporting, the reporting structure, and the signals must be distinguishable as synthetic. We cannot send false alerts to support if there's an actual say outage. So if we start looking at running tests that even possibly we are purposely failing those tests to do for instance testing our own test engine, we need to make sure that these tests ultimately distinguish themselves as automated testing. So we're going to look for any sort of path that will say that this is flag it as this is a test, or any identifiers that could tell us that this came from a test engine, not an actual user working within the app. Finally, any outages, be it the test engine, the infrastructure running the test engine, the apps themselves, they must be identified immediately, ultimately trying to reduce the time to recovery. If there is an issue, we need to be notified and essentially let the support and development teams quickly be able to deploy to reduce any sort of failure time and get back up and running. So these are our sort of key indicators of success that we're going to have as we build a testing strategy. That said, let's go ahead and look at a proposed testing strategy. Okay, let's take a look at this strategy that I've outlined here. So this is a Power Apps testing strategy. You can see here on the top left, we have a testing engine. On the top right, we have an application and all its dependencies, in our case, Power Apps. Finally, in the bottom left, we have reporting and alerting. So those icons here will be Azure Monitor for alerting, for log storage and so on, and Power BI for dashboards and reporting. See, this one now has expanded the testing engine just to look and see how we're going to strategize here. So we have a test runner, right? So this will be an agent, if you will, that is going to run on a workflow in GitHub or an Azure DevOps, a build agent, release agent, something like that. They can run Windows machine, Linux machine, and run custom container with all dependencies, whatever you really want to run, Microsoft hosted or self-hosted. What you see going into it on the left is test engine and test scripts. So the test engine in this case will be Power Apps Test Engine. Why did we choose Power Apps Test Engine? Well, Power Apps Test Engine is supported by Microsoft, completely open source. does not require any sort of license to consume the test. Now, to execute a test, we will be a licensed user. It's an interactive user. But to build tests, to work with the source, to build on top of it, doesn't require any sort of license. And you can use the supported version of Power Apps Test Engine and build on top of it. For this strategy, remember, we want to reduce complexity. In this case, we don't really want to have ownership of code, even though we most certainly could. In this scenario, we're just simply going to take the Power Apps Test Engine source as is and run our test upon those. That said, we have to still be able to supply tests. So you can see on the top left, in parallel, we're going to be working with another GitHub repo. This one can be a private repo that may be internal to you on GitHub Enterprise, something like that. And that will host our test scripts, any configuration, environment variables, things like that. So that'll be independent of the publicly accessible Power Apps Test Engine. The test runner will actually clone both of these into it. So it'll have all the files, and it will go about using the test engine to execute the test scripts repo. Okay, regardless of the testing engine, if we chose GitHub Workflow, Azure DevOps Agent, we ultimately want to be able to test a Power App. Where we can get the most benefit here is having a Power App that has a instrumentation key from Application Insights provided into it. This is on the app object on the Power App. We can do this when we're developing the app. We can attempt to apply this and source control as we look to validate that the app has instrumentation and add that into it. One of the benefits of having the Application Insights key set up is that we'll see that a user launched an app. And yes, we can get that from Microsoft Purview, but we could see not only that it was launched, but what browser, where it was launched, and any other custom dimensions that may be part of that. That'll be in the custom event table in Azure Application Insights. The home page, the first screen that loads with the Power App, we also will collect that as well in the page view table in Azure Application Insights. The benefit of that is that it will show us that it successfully loaded the page and how long it took to load the page. So just by running this test here with the instrumentation key, we're able to collect the app was loaded, but then also how it was launched. So the one thing you don't necessarily get within Microsoft Purview or these audits is what's happening within an app, and that's where Application Insights will help us understand the user activity and their interaction with the app. And so loading it provides that to us. The test log itself can provide that as well. By executing the test, we could see it, but this will give us a little bit more insight into like duration and so on. And ultimately, we can tie the App Insights logs into our reporting and alerting tooling. As you see here, we have our test reporting and alerting. We'll use Azure Monitor to build alerts, on failed tests or tests that may not meet our business expectations. We can also use Power BI here. Power BI will give us the ability to query App Insights, be able to query the runners of our test itself, the container logs, etc. We can have robust queries that allow us to drill down or drill into data, slice and dice that data, provide a sort of a rich contextual dashboard that can show highlight performance, highlight failures, and help us sort of find that signal that we're looking for as we look towards identifying where there could be performance degradations as we release maybe new versions of apps, or if we see apps that maybe are being accessed across the world, maybe different versions of browsers are impacting how the app is launched. So all of that can be built into a single pane of glass using Power BI. We can alert with Azure Monitor, alerting through things such as Teams, email, DLs, etc. We can build automation so that we can do things like maybe alerting that we need to maybe redeploy a different version of the app based on source. There's all sorts of, you know, things that we can do with alerting in Azure Monitor. And stepping back, here is again the full testing strategy. From here, we're going to go into a demo and kind of see it in action. Let's take a look at the demo. Okay, in this demo, we're going to look at recreating our test strategy. The test strategy was, again, to minimize the code base that we would ultimately own. So in this case, we're actually going to just simply reference the Power Apps test engine code. This is one option. Obviously, there's another repo as well that we can use that will do the UI automation piece. But in this one, we're going to try the Power Apps test engine that allows us to take the PowerFX test that we create with Test Studio and recreate it. So we're on the Microsoft Power Apps test engine. See the code here. It's great. It tells us how to, build it locally, use the provided samples, etc., how to authenticate with a user, set this up, and so on. One thing you'll find is that it'll show you how to do a workflow in GitHub, and that is here at the top in the workflows folder. And you see here build test and then YAML integration test. So we'll take a look at each one. We see what are they doing, running it on a Linux-based machine, checking out the code, installing dependencies with .NET Restore, .NET Build to build test engine. Going to run some testing here, and then use this test reporter tool to report on test, report on code coverage, and then look at adding a PR comment here, and then running essentially the test with these sort of hard-coded test plans that we have, and it'll run it into prod, pre-prod, and a test environment. It looks like there'll be a notification here that will send notification for failures or reruns to send a notification to teams. So we have that available to us. We go look at the other YAML. We see that there's a changing directory into Power Apps Test Engine, building it, running this playwright install, and then running this script with the input parameters that we got from the previous run here, and then doing the sample test. So this is all available to us here. Within my repo here, this will be essentially, think of this as hosting my own personal tests that I have, the test scripts and so on. So you can see I have a test folder, Canvas app development using Edge, Firefox, one using Chrome by default, even testing the ALM accelerator config, I think it is, and then our test suite. So we'll look at this here. We'll go to my version of the workflow. So we'll go into workflow. So I have a name of it called Import Power Apps Test Engine and Run Test Suite. You'll see that it fires off on push, so adding of a test, for instance, or it also runs on a schedule. So in this case, it's going to run every 15 minutes. It's going to run on Linux, just the same, version 6 of .NET. What you'll notice here is that we have two checkouts, actually. We have a remote repository using this repository keyword of Microsoft Power Apps Test Engine, and then we have a local checkout, and we're providing a path so they don't overwrite each other. So we'll have one called test that checks out this particular repo. Same steps as before: restore Power Apps Test Engine, build Power Apps Test Engine, integration test. We're going to source into or change our directory into the source, build it, run the playwright, same as you saw before. What's different here is this line on 51 is hitting this test suite JSON object. And why are we doing that? We're creating a variable that allows us not to hard code our test that we want to run within the script. So in this case here, I can simply update the JSON and have it go here. And finally, it'll run this command here using the run the test report as well. And here we see we have a test suite with different apps, tests that we have. We see each one of these has the name of the test suite name, test description, which app we're going to test, what's the steps. In our case, we're just simply going to take a screenshot and show that it's loaded. For this one here, I have a Canvas app dev workshop, running availability test, running it on Firefox, running it on Edge, and running it on Chrome. So here's all the tests within a folder. We have a test suite.json. In this test suite.json, it's actually here. Let's make this a little bit bigger so you can take a look at it. We see an array that's here with all the different ones. Now, right now, it's a single line, which is something to do with the variable I'm doing in Linux. We'll figure that part out later. For now, it's going to read this way. The big thing I would say is when you're looking at the differences between mine and the one on the test engine is that you'll notice there's no double quotes or single quotes here. So that's a big one. And when you start working with the Linux variable here, so we have that going, and seems to work well. I'll do test report. A key one here is this failure. So you can decide how you want to run this test report, a success or failure. We're going to run on both. We want to be able to report that it's successful. But part of this one is this fail on error. So this isn't there by default on the example from the Power Apps test engine, but I would turn this one on. You could fill this out. And where this is helpful is if you're building a badge, for instance, for this particular workflow run. So finally, we upload build artifacts. That'll be our test results that we've done. So you can see one that we've started here. Here's a basic build. We can go inside of it and see we're checking out test engine. We're checking out test, reviewing directory, installing dependencies, building, doing the actual test itself. You can see grabbing everything it needs and then running all of this. And these are logs that will be available as an artifact on this build. And how we can get that automatically, we'll talk about it in next steps. But you'll get a test report, and then you'll finish it up here. So some examples, you can see one that's run successfully here. You can see one that has multiple tests. So this one is run many times. Each one of these has its own test results file that includes a case number and so on. Here's one that's failed. You can see here, so I can report on failed. This will allow me to add a badge, for instance. So if I want to look at a badge, I could say create status badge, and you can see this one's failing here. You could choose what branch you want and what event is happening. And so you could have, say, a markdown file that has the badges for all your different tests if you want, or a report, something like that, because it'll just be this markdown. It's really a link that you'll have that you can reference here. So you'll configure the action just like you would any other. You'll configure the environment variables just like you would every other. And then you have that here. When you download the test results, you'll see here this test run. I can download this. Let's take a look. Just extracting it on another monitor, and I'll bring it back over here. We'll run our test results. See our logs. So running in the US shows our test results. If I go look at the debug logs here, but here's the actual test with the case that I ran with the debug logs. Ran the case with screenshot, took a picture of it loading so I can actually see here and so on. So we confirmed it loaded. We have debug logs. All this is now available to us. We even have a recording of it logging in. So if I run this, I could see recording. I could store all of this in, say, a data lake or storage account, something like that. So you can watch this. You can watch this. So on. I dig through it. Here's actually the recording itself. If I wanted to play it, you can watch it. Sign in and do its thing here. So you have this. See signing in. So we have that. Finally, you'll if you have App Insights set up for the test, you can now see here we have the custom events showing that has been started. There's the on start. One of the big ones here is test. It's going to show it as false. So how can I determine, again, one of our rules was we needed to be able to determine this is synthetic. Well, this one doesn't do this. Test Studio will set it to true. This is set it to false. What you can look for is something like Linux, for instance, headless Chrome. Well, Linux, maybe there's users who are running something on an iPhone, an Android, or running it on whatever their device they're running on, maybe running that. But headless Chrome, traditionally headless is not something a user will do. They're going to be running in an interactive state. This will run behind the scenes. So you can look for that and kind of confirm that this is a synthetic test. So there is sort of a gap that does show is false, but you can look at the browser and set up an alert that says, hey, we know that this is going to be run from that. Or, I mean, alternatively, have a test user that you can use. This is an ID that's available in Azure AD. What's interesting about this is now we can start also looking at the duration. So I could see this one took about half a second to load. And I can go to other apps and start seeing those as well. See headless Chrome. And I can run this on page view, like page view and custom events are the two tables here. So I could see screen one on whatever app this is. This is Canvas App Workshop. This one took 275 milliseconds and was run on Firefox 99 from San Jose in this case here. So we can see different ones, and you can build reports off of this. If I want to build an alert, build an alert here, and so on. So this is a good example of us getting started with this. The cases passed and skipped here. So I highly recommend, if you want a good starting off point, is just go look at my repo, grab the clone build test YAML, look at this here, the cron, how to set that up. That'll run it on a schedule. As you can see, if I go look at actions, I can see scheduled. It shows it here, yeah, scheduled, scheduled, scheduled. And you can go into each one of these and look. So there's a lot here. You can do this with DevOps or Azure DevOps as well. Maybe cover that on a different one. But for now, that wraps up this demo. Let's take a look a little bit at the details of our workflow. Okay, here we see the GitHub workflow YAML file. I tried to screenshot as much as possible. There's a little bit underneath when it comes to the test reporter. Remember, we have the failed test property that needs to be set. But let's start here at the top with what we just covered. We see at the top we have a step that's called checkout test engine, and that you can see we're using the repository attribute that allows us to hit a remote repository. We see the next one is checking out the actual repo that this YAML, this workflow is tied to. What's key there is the attribute path. We're putting it test, and what that lets us do is create sort of a folder structure in the original cloned repo that has the content of this repo in the test folder. So that'll allow us not to sort of step on the previous checked out repo. You can see in the integration test, specifically in the run area, that we are going to run, specifically that export line is going into this test sort of folder. So when you look at the sample repo, you'll see that there's only a single test folder, but because I'm putting it into another test folder, it's actually test/test/test suite JSON. And here the big ones are the secrets. You need to go into GitHub and set up secrets for the email and password. All of that documentation can be found on the Power Apps Test Engine repo README. This run here is changing the directory to go into the source for Test Engine and to build it, to run the Playwright install, which will get all of the browser drivers. It'll change a directory to go to the scripts where our scripts will be at, and we'll modify the bash file. We'll export myvar. Now the sample I have online may change the name of the variables. Maybe some of this stuff here may be removed, like the change directory. may be moved. Point is that you need to use that export keyword for the bash variable. And then you want to wrap that into double quotes when you run it against the script. You'll see in the JSON that I've, again, taken away the double quotes. This just makes it something that can be consumed by the script here. Finally, again, on the test report, make sure you're doing success and failure, not just failure. We want to be able to run this so we can see successful ones and failed ones. And if it fails, you'll still have a badge that you can refer to. And remember, always setting that fail on error is key. Okay, so now that we've ran our workflow, what do we have? On the far left here, we're showing us a picture of App Insights, specifically some of the custom dimensions that are available on a page view. So the page view, in this case, will be about the opening of the first screen. So we can see the app ID, so that'll tell us what Power App we've opened, what's the more friendly name of it. What was a session ID if we needed to sort of correlate this to any tracing. What index we were on. So we know that we started on the home page, so we're going to start on index 0. The ms dash duration is key here. That's in milliseconds. So this one opened up in 434 milliseconds. So we can get very granular on how long it took to open this one. We see environment ID is test. Again, it's showing false here. What we can look to do is to take that session ID, potentially look at the logs that are within the TRX file. Again, we can look for, if we're running Chrome, look for things like headless Chrome or the user. Remember, the user, if it's a test user, would also be a clear indicator that this is a synthetic test. What you see in the middle is some automation. So in GitHub, you can set up a workflow to run on complete of a run or suite. If you're in Azure DevOps, you can run on complete of a build, for instance. So we have a webhook. In this case, it's a Power Automate flow that's looking for a status of complete, and it's going to parse that JSON body and then send a notification to Teams. So that'll set up sort of that bell icon that's in Teams and let you see that, hey, this may have failed or passed, and let's click here for more information. You can build action cards, things like that. On the right is actually a picture from Power BI of container logs, or in this case, the logs from the workflow itself. So you see at the top, we have the agent job starting, how long it took to run it, different phases and stages and tests, like the tap. How long did it take to check out the repo? How long did it take to export a solution, extract solution in that case, or in our case, maybe to run each test. So maybe we could start looking at how we can make this thing be more performant, right? Part of our OpEx solution needs to be something that can be performant and give us information as close to real time as possible, and look to optimize that, right? So operational excellence also is something that has to be optimized. We need to refine. So we constantly look at the logs that are given and what can we do to tune this to make it more performant. Let's look at references and talk about next steps. All right, we'll wrap with some references. The very top reference is a link to the Global Automation Bootcamp. In 2021, I led a session talking about collecting Azure DevOps build logs, collecting GitHub workflow run logs, using Azure. I think at the time it was Azure Automation. It could be anything, but to collect and to store these within log analytics so that you could build alerts and reports off that. So I recommend watching that. There's some sample code links there as well. The next link is a link to a markdown file that eventually will be included in a blog that my CSA colleagues use to showcase some information samples. So there's a link to that. The next link is the actual Testing Power Platform repo where the sample code and everything is at. The final two links are both of the Microsoft open source test engines. The first one's the test engine, which we covered in the sample. The second is the Power Apps test automation. It does the UI automation, where this can be using Selenium, can be used Playwright. This one will go in and launch the Maker portal and go submit the URL. So it gives you a little bit more sort of what a user would do traditionally. Open a browser, log in, and execute a test. On the right, we have the samples. That's the clone-build-test is the YAML for the workflow. All of these links I'll provide in the description below. Okay, looking ahead at some more video entries and blogs I plan on writing. So I plan on looking at how we can test these Power Apps at scale, looking at load testing with containers, Kubernetes, maybe Azure Container Apps. We'll decide how we want to go with that. Looking at how we can maybe try to make this sort of a no-code approach by having something help us describe and generate the test suites and test cases for us. Also looking at some A/B testing concepts. How can we sort of present a test or a app to a user and collect, how their sentiment is of it, their feedback of it. So let's look ahead towards some additional content coming very soon. Well, we've made it to the end. I really appreciate you watching this video. I hope it was helpful. Again, my name is Ali Yousefi. I am a cloud solution architect at Microsoft. You have my information on this channel. You have my information at the beginning of this video. I look forward to hearing from you if this was helpful. If you found anything that was maybe off or has changed since I've recorded this, please don't hesitate to leave a comment or reach out to me directly. Thank you. Have a great day.